Welcome to our session on maximizing actuarial efficiency with Python, Git, and DevOps. Before we get into those exciting topics, we have a little bit of housekeeping that we need to take care of. One is participants in the conference. We are really trying to adhere to strict antitrust laws to make sure we have a fair and competitive environment. If you read through these, some really important things. Please don't talk about pricing, market allocation, membership restrictions, product standardization, really anything that reduces competition. And if anything we talk about today goes into that area, please leave the meeting and report the incident to the conference organizers. We also really want to thank the sponsors of this summit, in no particular order: the Standard, Dataiku, the Gunter Group, and Oliver Wyman. Without their support, we wouldn't be able to be here and share this all with you. So we really appreciate them all making this happen. Another really important thing, please remember that the views and opinions that are in all the sessions, including this one, they're the opinions of the presenters, mine and Anton's opinions. They're not the opinions of our employers, the sponsors, or really any other entity. These are the ideas that Anton and I believe and we want to share with all of you.
Thank you, Aaron. Let's discuss our agenda for today. We'll start by introducing the topic, our goals, and ourselves. Next, we will dive into the core of the session, covering the Python programming language, the benefits of adopting Git, and DevOps principles. We prepare some slides to introduce these technical concepts, and we'll also do hands-on demos for each topic. Finally, we will wrap up with conclusions and Q&A. To be transparent, this is a pre-recorded presentation. We should make it easier for us to take questions along the way. Most questions we may answer live in the chat, but some more nuanced questions we may want to save for the final round of Q&A. What's our goal for today? What problems are we trying to solve? Why is this presentation important? For context, actuaries rely heavily on data and the technologies they use to work with data. The traditional actuarial tech stack has been dominated by Microsoft Excel, which is excellent for some purposes, but not for others. Our goal for today is to illustrate how adopting Python, Git, and DevOps principles can help improve the efficiency and reliability of actuarial operations. Just a few examples of what we mean by challenges and tech stack limitations. Have you ever dealt with slow spreadsheets or an Excel workbook that crashes all the time? Would you like to explore alternative statistical analysis or data science, but it's hard to do in your current setup? Have you dealt with poor version control? What if before revise final is not working? Can I use before revise instead? What are the differences between these two files? Lastly, maybe there's something you'd like to change or automate, but it's too risky because there's no easy way to know if a change will break something downstream. This is particularly true if you're inheriting a formula-heavy workbook and there's no easy way to tell what is the calculation flow and what depends on what. Back to today's goal. Full disclaimer, we have less than 1 hour, so obviously this is not a complete course. The good news is there are plenty of resources online, so please reach out to us if you'd like to learn more about any of the topics presented today. About the presenters, who are we? My name is Anton and I'm a senior consultant at the Gunter Group. While I am not an actuary, my background is in engineering and I am deeply passionate about data, analytics, and product management. Since 2021, I've been involved in the Standards Actuarial Transformation Program. During this time, I had the opportunity to apply the technologies and principles we will discuss today to various actuarial processes. This includes building data pipelines and implementing quality checks for valuation teams, as well as transforming Excel-based tasks into streamline solutions using Python and SQL databases. Notable projects include experience studies, profitability analysis tools, and financial reporting tasks. I'll pass it to Aaron.
Thanks, Anton. My name is Aaron Smith. I am a credentialed actuary, a fellow of the Society of Actuaries. I've been credentialed about 6 years or so. I work at the Standard. I work remotely based out of Indianapolis, Indiana. As part of as my time being an actuary, I've seen a lot of different sides of actuarial practice. I've worked in valuation, I've worked in enterprise risk management, model development, model production, some non-traditional roles, as well as time and pricing. I've always been really passionate about technology and better ways to automate things and how to spend our time doing really more fun and value add activities. As part of that, I want to start talking about some of the things that I believe are desirable features of an actuarial programming language. If you're going to equip your actuaries with a tool, what are some features it should have? Well, number one, it needs to be easy to learn. That's really important because there's a lot of actuaries who have no training at all, no formal training, I should say, as programmers. Another thing, it should have a large package ecosystem. If you're not familiar with the idea of a package, what a package is, it is a tiny piece of software you can add to your project, the thing you're working on, and it lets you do something new. Maybe it's a data science package and lets you do data science. Maybe it's a plotting package and it makes you draw pretty pictures. It's just a way to bolt on features without you having to write it all yourself. You also want something that has strong support, right? If you run into an issue, you want to be able to figure out what the problem is. If it's a very niche language, you're not going to be able to find a lot of people who have run into similar problems. Actuarial science and data science are converging more and more. And so, if we're thinking about an actuarial programming language, some tool that has those data science methods easily available would be very important. Something that's performant. We don't want to spend 30 minutes waiting for our problem to finish. The faster it can be done, the better. This is an interesting one, easy to safely change. Really what we put in here when we were thinking about this was actuaries like to experiment and change things. What would happen if I change this setting? Or what happens if I made this assumption? You need to be able to do that safely because a lot of the things we work on are regulated. They are very thoroughly audited. You need to be able to very safely say, I changed this. This is having the exact impact that I'm expecting, and I'm very confident I'm not changing anything else. This is something that's not really easy to do in many of the traditional tools actuaries use, like Excel. So it's really something that we feel is very important for an actuarial programming language. And last but not least, cost. If we're talking about equipping a department of 100 actuaries, a tool that maybe fits all these criteria but costs $20,000 a seat, that becomes a very important consideration. In our mind, we think that Python checks almost all of these boxes. We'll talk about the performance one in a second. One, Python's very easy to learn. We're going to go through a demo today, and at the end of it, you'll be able to understand some really basic Python stuff. And we'll actually provide that file to you so you can play around and experiment on your own. Python has a very large package ecosystem. As of the time of this presentation, there is about 590,000 packages. Obviously, there's a few out there that are much more popular than others. Those do not have equal popularity. And we'll talk about some of the really popular ones, but chances are if you're wanting to do something, there's a Python package for it. Incredibly strong support. If you ever run into an issue, you can always Google it, and almost every single time someone has run into the exact same or very similar issue. Python is the language of data science and AI. Many of the most popular packages are easily available in Python. Performance is a place where we did give Python a little bit of a knock. Python can be slow compared to other languages like C++ or Rust or Julia, which is another session you should go check out. In our use cases, that has not been a problem for us because we've used packages that are very performant, like NumPy and Pandas, which again we'll talk about a little bit later. Just know that Python can have some issues with performance if you're not using optimized packages. Python's also super easy to safely change with the testing library called PyTest, which we'll do a demo of today. And last but not least, Python is free. Can't argue with that. We'll now jump into a quick demo and talk about some of the packages. Really today we're going to talk mostly about Pandas and Jupyter are the big ones that I'll talk about with a little bit of sklearn towards the end. And that's a scikit-learn machine learning library. And then I'll have Anton talk about PyTest, PyLint, as well as Cookie Cutter. We're not going to talk about Excel wings today. Just know if you want to interact with Excel, it's a very common package for doing that type of thing. All right, so what we have open here is a programming environment or an IDE called Visual Studio Code or VS Code. It's free. You can just Google it, download it, and it has lots of extensions for languages like Python. Over here, you can see our files view. I'm actually going to shrink this down just so that we have more screen real estate to work with. And what I'm going to show you here is what's called an interactive Python notebook, IPy notebook, or a Jupyter notebook is another term for it. And so whenever you see .ipynb, that's what this is. And what it is an environment where you can have executable code cells. So I could go here and I could write hi, and I could then execute that cell. And you can see it's immediately changing whatever I do there. So again, this is very nice for iterative, trying something out, running it, seeing what happens, make a change, try it again, see what happens. You can also have text in here. So as we'll send this file to you so you all have access to it. We've added some narrative. I won't read through the narrative because I'm here talking through it, but we wanted to read it, leave it there so you could follow it on your own. So to start with, we are going to use a package called Pandas. It is a very popular data analysis library. It is incredibly useful for actuaries, and it is super performant. The way you bring it in is you first have to install it. If you don't have Python, you can just use this command in a notebook and it will install it. And then you bring it into your project. So I'm saying import pandas. I'm giving a nickname as PD. Call it whatever you want, but this is what everyone does. So highly recommend you do this. So from now on, for the rest of our project, we can use PD dot, like here, and we have access to all the things pandas gives us. First, we need some data. I'm going to use the read CSV method. You can see if we go here, there's a bunch of other read methods. There's read clipboard, Excel, SQL files. Again, lots of different methods. We're going to read a CSV, and this is the Titanic data. That's going to store as what's called a data frame. Think about that like an Excel sheet. There's rows, there's columns. And then I'm going to show you the first 5 rows of that with this .head function. So I'll run this cell. I could click this little play button, and that would run it, or I can use a keyboard shortcut, Control-Enter. You can see here we have rows, and then we have columns. The Titanic, obviously these are the passengers on the Titanic. We have things like name, age, sex, as well as passenger class, and then survived or not. If you're not familiar with the story of the Titanic, it's a large ship that sunk, many people died, and so people that had 0 did not live. People that have 1 here, they ended up living. So at first, Pandas assigns each row an identifier, and you can see it's just a number. We already have a pretty good identifier, name, so I'm actually going to set that as what's called our index. In place equals true just means it modifies it in place instead of creating a new variable. So now you can see when we run this, instead of having this kind of meaningless number, now we actually have something that makes sense, a name. First thing you want to do is, instead of looking at your entire row or entire sheet of data, what if you want to select a subset? So the way you do that is you use your data frame .loc, that's location. And then within there, you have the rows you want to return, and then the columns. So in our case, we're saying, I want to bring back all of the Alan, Mr. Henry, William Henry rows. And then when you have a colon, that means I want all of the columns. So we can run this, and you can see it only returns the record for that one person. In this case, we're going to say, I want to bring back all the rows, but I only want to bring back 2 columns, the survived column and the age column. You can see when I run this, now you can see survived and age. Name is not technically a column since it's our index, but you can still see it there. And obviously you could mix these two. We could put this in this first part, and it would only return this row and those 2 columns. So you could subset that any different way you want. Another thing you could do that's very common is you can create a new column by doing operations on existing columns. In Excel, this is adding a new formula to the right of your data, right? So what we do here is we have to give our new column a name, and I'm just going to be multiplying age by this survived field. So I'll make a not very fun name called age survived multiplied, and then you have to assign it a value. So it's going to be the age column times the Titanic data survived column. Then I'll show you what that looks like. So you can see here, survived is 0, so age times survived is 0. In this case, survived is 1. Age times survived is now just the same as the age. So you can see it did as we expected. Any sort of math operations work here as well. You can do a lot more complicated things, and we'll give you an example of that a little bit later. Now we've done something interesting, adding our new column. Now we want to save our data out, right? So instead of the read methods, you now do dataframe.to, and they'll be very similar to CSV, to Excel, to SQL, so on and so forth. So I'll run this. I'll pop open our files view again, and you can see that now our data is in a CSV. And if I wanted to open it in Excel, I could just open the CSV in Excel, and I could play around with the data there if we wanted to. Let's do something a bit more interesting now. So let's take our data and .describe. What that's going to do is going to take all our numeric columns, and it's going to give us summary statistics. So we can get a feel of what is the average survival rate, about 38%. What's our average age? About 30, a lot younger than I actually thought, as well as things like the standard deviations, min-maxes, and some percentiles. It gives you a really quick overview of your numeric columns. Now there's another method called .info. What this is going to do is it's going to tell you all of the columns, how many of those are non-null, as well as its data types. So ints, those are numbers without decimals. Floats have decimals. Object, that's a text column. Let's take another data set, and we'll create that here. I'm just going to make up some random factors that vary by gender. And again, I won't read through the code. You'll get through this notebook. But you can see we have a new table that's a male factor and a female factor. Again, meaningless, but just to show how you can bring different data sets together. A couple different ways to do it. I'm going to use this pd.merge method. And so what this takes is a left data frame and a right data frame. And we need to then tell it how we're going to bring those things together. And you can see if we hover over this, it's very well documented. It tells us exactly what that variable's different options do. In our case, we're going to take the gender factors and smush them onto the Titanic data. So that's a left join. And you have to tell it what to join on. Column in our left data frame is called sex. Column in our right data frame is called gender. Now when I run this, you can see those two things are brought together. So now we've brought our data frame together. You can join on multiple columns. There's also other methods that allow you to do things like join on, sex and gender, and then join on the nearest birthday or the nearest without going over. And that's this merge as of method, which you can play around with a bit. One other quick thing I'll just share. I'm not actually saving this, so we're not going to see these going on, but we just wanted to illustrate how easy it is to bring data together, because how often are we doing things like a VLOOKUP in Excel to bring data from two tables together? This is really the same thing, but has a lot of things where you can start, checking integrity and making sure that every record had a match and erroring out if they didn't, or things like that. Let's go now start doing some more analysis here. So we have our data, but what is it telling us, right? What are some insights we can glean from it? For that, I love using what's called group by. So Titanic data.group by. Then you have to give it a variable. We'll pick sex. That's an easy thing to see differences by. But then you have to tell it how you want to aggregate or group that data. In my case, we're just going to use mean. You can see here, I told it numeric only just because, again, that's really average of a text column. Doesn't really make sense. And you can see here now, it's taken all the numeric columns and it's given us all the different means. And if I wanted instead of a mean, I wanted to do a sum. That's super easy to do. You can see there's the sum. I'm going to go back to mean. What's it telling us here? Well, at a high level, 75% of females survived and only 18% of males survived. So some pretty stark survival differences if you just look at sex. If we don't want to look at all the columns, we can just pick one. That's called slicing. So we just add this little square brackets, pick our column. You can see the same numbers there. Now, if you really want to see something interesting, instead of just looking at it by sex, let's also add passenger class in the mix, and then look at our average survivals by that grouping. And this gets pretty interesting. So the first class females, 96% survival rate. So again, first class, that's going to be the upper class, really, really rich. Second class females, 92%. Even third class females, still 50%, coin flip of surviving or not. Very different story with males. Even the first class, very upper class males, only 36% of those people survived. And if you're a second or third class male, your odds don't really look too great. So that's a pretty easy story we can learn from one line of code. It's super easy to then say, well, maybe this is a small numbers problem. Maybe there's not a lot of these females, so this is not a reliable number. But you can do things like count. And you can see exactly how many are in each of those. You can also do multiple aggregations at the same time if you want, or custom aggregations for a thing like a premium roll forward, maybe. But there's, again, simple things to hear is all we're trying to show today. Another quick thing that actuaries do a lot is binning, right? Where instead of having discrete ages or benefit amounts, things like that, we want to bin them together. So here we're going to create a variable that contains our bins. So I'm just going to pick 10, 20, 30, 40, 50 ages. And then we have to store this bin in a new column, age bin, very inventive name. pd.cut, that's going to apply our binning. You have to tell it what column you want to bin on and then what the bin values are. And then when we run this, you can see that if I go over here to the right, you can see age bin. So this 22-year-old is in the 20 to 30 age bin. This 38-year-old is in the 30 to 40-year age bin. Again, super easy to do that with 2 lines of code. Last thing I'll show you here with pandas, and then we'll get into scikit-learn, is we did an example of creating a new column based off of some math, some multiplication. Well, in this case, I have just an arbitrary function. Okay, so all it's going to do is for every single row, I'm going to apply this function, this calculation. And what it's going to do is it's just say, hey, if your gender is a male, then I want the value of this new column to be 0. Else, I want it to be equal to 1. You could obviously be doing something a lot more complex in here. We're trying to keep things simple. NP-where is another way to do this very much less verbosely. But what we're going to do is create our new column called gender encoded, and then we're going to take our data frame and apply this function. Important thing here is axis equals 1 tells it to apply it to every row. Now when we run this, you can see that now we have a gender encoded. Males are 0s, females are 1. So it works as we expected. Let's change gears a little bit and talk about scikit-learn. So sklearn or scikit-learn is a super popular machine learning library. One important thing I do want to call out, we are showing the very basics here. Do not do data science like we're about to show you. We're not doing things like train test splits, cross-validation, anything like that. We're doing, again, the very basics just to show you how it works at a high level, but just know that sklearn has very elegant methods of implementing those features. So at first, we're going to bring in sklearn. I'm going to bring in a tree method, specifically a decision tree classifier. We're also going to bring in matplotlib, which is a plotting library, just so we can customize what our picture looks like so we can visualize our tree. One quick thing you'll notice here, if I hover over our decision tree, there are 101 different options here. I'm going to keep one very simple, just set the max depth equal to 3, just so our picture is understandable. Then what we have to do is tell it what we want to predict on. So here we're going to use passenger class, our encoded gender and age as our predictors. And our target variable, what we're trying to predict, is going to be the survived column. So we've set our x's, we set our y's, and then we call .fit on our decision tree classifier. And so this is going to say, okay, well, what's the best way to predict y based on the x's you give me, as well as the model configuration options. And then we're just going to plot that tree. So click here. You can see in about a couple seconds, it'll plot the tree. So I won't go through this too deeply, but you can see the first thing it does to make that prediction is it splits on gender, which makes sense because gender is such a huge driver of survival rates. So males will be this side of the tree, females will be this side of the tree. Then for males, the next thing it does is it splits on age. And it looks like it splits into child, people less than 6.5 years old, or more than 6.5 years old. So anybody teenagers or up. For females, it's actually different. The next most important thing is the passenger class. That's what's going to drive things more than anything else for females. And it continues doing that down the tree as many times as we've allowed it. And that's how it is going to best predict based on the constraints we gave it. Okay, cool, great model. How well does it work? Well, we can use things like metrics. I'm going to pick accuracy, which is just how often is our model right. To predict that, or to really evaluate how good our model is. So what it's going to do, we're going to call our accuracy score. We have to give it the real values, as well as we have to create a predicted value for all of our x's, and then it's going to compare the two. So it's right 80% of the time, which is pretty good, given we're being pretty high level here. Now, one thing to keep in mind, what we're showing here, a Jupyter Notebook, is super good for trying things out. So if instead of using a max depth of 3, maybe I want a max depth of, maybe not 10, we'll go 5. Let's see how well that does. So it just took 1 second to go change that code. You can see we have a totally new tree, a lot more complex. How much did it actually help our accuracy? Not a lot. We're probably doing some sort of overfitting in here, maybe. Jupyter is great for those type of things. Notebooks are awesome for that iterative development. But once you really know what you want to do, typically we then take our code and put it in a package, which is like what this is, in a .py file. And I'll hand it off to Anton here to then start talking through how you can take this code and then harden it.
Like Eric mentioned, there are many times that you need a flexible environment to explore data and explore new methodologies. And Jupyter is absolutely great for that, especially if you are working with larger data sets, let's say 2 million rows instead of 10,000, and you are exploring more sophisticated data science techniques. Now, actually, my favorite part is when you're ready to make all that exploration into something more robust, a more reliable, tested, robust product. And there are many actuarial tasks that you can think of them as a data pipeline. You have to get data from a source, you do some transformations, and at the end of it, you need to save or export some results. It could be, of course, more complex than that. You have 10 different sources, Oracle, SQL Server, Excel files, public URLs. Then you have some curation and validation and many transformations, and you're saving multiple output results. Either way, that's where these .py files and a built-in testing framework like PyTest really come into the picture. So for this demo, I want to use as an example this get mortality data function. And I want to picture that this repo, this project is owned by Aaron Smith. He's the main developer, and he wants to onboard me into his team. And because we love continuous improvement, from the get-go, I could love to start adding value and contributing to the project. So lucky for me, this function, get mortality data, already has some tests in this test folder. So if I go to this other file, you'll see that there's actually all the tests are used in that function, are calling this function. So even before I make any changes, the first thing I'm going to do is to check that all the tests are passing. And if that is the case, then we're good to go. And I should leave the repo after I make some changes. I should leave at least at the same, if not better state, compared to when I started making changes. So back to the function, just to see what this function is doing. The core functionality is reading a table that lives in a public URL, and we need to provide a code, either an M or an F, depending on male mortality data versus female mortality data, for which we have one input parameter, gender, which is a string, text. We convert male, no matter if uppercase, lowercase, we're transforming that. And then once we have M or F, we call the function and we return a data frame. So the first thing that I notice in my VS Code is that there's a blue line under the name of the function. And if I hover over with my mouse, and in VS Code it's telling me missing function or method docstring, PyLint, and there's a link for more information. I already know that this is a great segue into PyLint. PyLint is a package that analyzes your code without running it, and it's very helpful to get suggestions. It's gonna let you know about warnings or things that may be wrong. So in this case, it's a suggestion, but I think it's a good idea. And a docstring is really one or more lines of text right below the name of the function to explain what the function is doing. So really this is missing a bit of documentation. So that is exactly what I'm gonna do now. So I enter a new line, triple quotation marks in Python, and I may say get gender specific data from public URL and return as a data frame. That's a good addition. It's very low stakes, but even then, I'm actually gonna run the tests again to see if anything is breaking. Now I expect everything to be green, perfect. I can keep going. The second thing I'm gonna change for this demo is gonna be a bad change initially. So what I notice is that we're calling table ID this, gender code, and I think it would be more readable if this variable, if we rename it to just that, to just gender code. So what I'm gonna do is I'm gonna rename it like this, replace it here, but now I'm gonna forget to change it here too. So I'm expecting this to break, but oopsie doopsie, I forgot. I run my test and I'm expecting it to fail because there's no way that the program now knows what table ID is. So if I go here, everything is failing, and I already get a really good hint into what happened. So I can, in VS Code, I can pick this error, and it's saying this is the exact line of code that is failing, and it's saying an explanation for name error, table ID is not defined. And yeah, of course it's not defined. I made a mistake. I can go back and I'm gonna say, okay, either I define table ID before we use table ID, or I finish the job and use gender code here too. Now this should work. So I'm gonna run the test again, and I'm expecting everything to go back to normal. So everything is passing now. That's great. Other things that I could have done include refactoring, and probably there are other things we could do. For the sake of time, I wanted to actually spend a few minutes mentioning a couple packages that are probably useful for many of you. One of them is called Black, and this is for Black auto formatting is for the community of people that have worked with VBA. And even if you love VBA, I'm gonna bet that you don't love the VBA editor. For me, for example, I really like having a very clean, organized, consistent indentation and new lines and spaces in the code. That is what Black auto format is gonna help you do. So if I quickly make this code uglier, so adding like some spaces here, maybe a bunch of new lines here, and yeah, again, like maybe some new lines like that, or make this like a very long line. Now what I'm gonna do is I'm gonna save the file, and the moment I've saved the file, Black auto format kicks in and goes back to a clean, organized indentation. Another package is called Excel Wins. So for those that again use VBA, Excel Wins is gonna give you a way to have a very similar syntax and perform operations on a workbook. That be writing to a cell, changing the font, adding rows, adding worksheets. And also something that I really like is that there's also a very easy way to see any data frame in an Excel workbook. For those times that it's not enough to just have a peek or just see the first 5 rows, you wanna really touch the data, put something in yellow. You can do that very quickly with x.eu data frame, assuming you previously imported Excel Wins as XLOB. But for the sake of time, I'm gonna move quickly through this and mention the last package that we would recommend you using also to make things easier for everybody. So it requires a little bit of setup, but it's called Cookie Cutter. And the idea of Cookie Cutter is a meta package. It's a package that creates packages based on a template. Just like when you create a new Excel workbook, typically you don't do it from scratch. You may use a workbook that you already like or that you used before. Here the idea is to have a template generator that is gonna create some of the subfolders and ancillary files like the README requirements, something for GitHub, and so on. So just for you to keep in mind. And now going back to testing, I would just highlight how by having these tests in place, when I came into the team, Erin achieved 2 purposes. First, he validated how the code was correctly working as he created it, but even more importantly, he locked in the behavior. So when the next person comes in, they know if they're breaking something or not. In this case, locking in the behavior means that when I run the code in get mortality data, parsing gender equals male uppercase as the input parameter, I should always get a resulting data frame with an exact length or exact number of rows of this number, and also a column year in the columns of the data frame. And of course, I'm expecting the code to not error out. Now I made some changes to the original file, but for now they're local, meaning nobody else knows about them, and that's where Git comes in. So let's move on to the next topic. So why Git? Even first of all, what is Git? Git is a version and source control system that tracks changes in files over time and allows multiple people to collaborate on the same project by doing all the heavy lifting for you, like merging code, processing approvals, and so on. When I compare this to a typical workflow in Excel with V4 revised final, where there is no built-in approval mechanism, and while I may have multiple file versions, for example if I'm working in SharePoint, I'm still not tracking the comprehensive list of changes between the different versions. So all in all, operating with Git is much more reliable and efficient in the long run. Before we dive into the Git demo, I wanted to pause for a second and explain a few concepts and technical terms, so hopefully, even if you were not familiar with Git, the next demo will make sense. First concept, branches. Think of branches as copies of your project. The latest approved version, that is what we call the main or prod branch. And the dev branches is where you test new code. Now, the source of truth for those branches, any branch, is the cloud. It's a centralized remote copy, which is probably hosted in a platform like GitHub or Azure DevOps. For my previous demo, before I started recording, I created a brand new independent branch. I downloaded the project to my personal computer. Then I started making changes, like renaming a variable. And I did this without affecting other people. Now, for next steps, I need to sync the changes to the remote branch, get some approvals, and eventually merge. So we go from, let's say, version 1.0 to version 1.1 of the main branch. A few technical terms related to this. A commit means saving a snapshot of your work locally. It's like clicking Save As in Excel, but keeping a history of every version. So at the end, you have a full history of commits in your main branch. Syncing is similar to downloading and uploading files to a shared folder. So in our example, I was making my copy visible to others once I sync. And then a pull request means proposing your changes to be added to the main branch. It's like asking your team to review and approve your updated Excel sheet before making it official. And now let's go back to VS Code for the demo. So this is where we left last time. I had made some changes to the data sources.py file, and let me close it for a second to clarify that this looks like this because I'm using VS Code, but this may slightly change if you're using a different IDE. In any case, in VS Code left bar, there's this source control pane where I can see a list of all the files that have changed since the last time I committed changes. In my case, I know that I only changed one file, that is datasource.py, and let me say, how cool is it that by clicking on it, I get a perfect side-by-side comparison of what has changed in the file. Not only I get a highlight, green lines where I added a new line and it's clearly showing as, like it didn't exist in the prior version, but also within the same line, look at this, I am seeing a highlight on the exact characters that changed in this line of code. Also, this one is not easy to see because it's a long line, but when I scroll horizontally, side by side, I can move both at the same time and see what changed in both. So, with that said, these are changes that I have not even committed locally. So let me show you what this looks like in GitHub. So in the browser, I'm looking at GitHub. This is our project, Actuarial Technology Summit, Python example. And if I browse to the data source.py, there are no docstrings. Still says table ID, and that makes sense because I did not even commit the changes. So let's go back to VS Code. I'm happy with the changes, so I'm gonna put a commit message like rename the variable and add it docstring to function. I'm gonna commit the changes. I'm not gonna sync for now. Say yes. And now you can see on the bottom left that is saying there's nothing to pull, but there's one commit that I should push and upload. I should sync my changes. Before I do so, let me go back once again to GitHub. I'm gonna refresh, and I'm expecting to see the same. So still no docstring, nothing. Minimize this, back to VS Code, and now I'm gonna sync changes. Click on the blue button, takes a few seconds to upload the file, and now let me go back again. I'm gonna refresh once again, and now I'm expecting to see exactly this. I get my docstring, gender code. Now it's ready for review for other users. Because I'm not planning on making other changes, I think we are ready to create a pull request. So this next step may also look different depending on the platform you're using, but they are very similar with the same concepts and technical names. So what I'm gonna do is I'm going to this pull requests tab, clicking on it, and it's already suggesting that dev and done, recent pushes 1 minute ago, would you like to compare it and create a pull request? So I'm clicking on the green button, and this has already all the template and everything. So there's like a suggestion for Erin Smith to be a reviewer of these changes, so he may eventually need to approve before anything gets merged to main. I could add a description here explaining that I increased readability and also fixed a pilot issue by adding a docstring to the get mortality data function. And I will, when I'm ready, I can create a pull request. One last thing I wanted to share before finishing the demo is that, similar to what you saw in VS Code, here I also get a preview side by side of what changed. So in this case, you can see the docstring, the gender code, and also a couple commits that I was testing before recording the demo, like renaming this as return df, or adding a comment with Python, so the hashtag transform parameter. With that, I'll pass it to Erin for the last topic of the day.
So the term DevOps is a term that gets overused a little bit. It can be a bit buzzwordy. A lot of new things have ops on the end of them. The end goal of DevOps, though, is if we cut through all that buzzwordy stuff, is high quality software or models released quickly. The term DevOps comes from bringing together development, the team building a software model, whatever it might be, and operations, the people running those models. Those have different priorities, different strengths, but the whole premise is by bringing those two teams closer together, you're going to have a better outcome in the end. And the way you do that is there's a huge focus on automating things, getting fast feedback rather than very slow feedback, as well as doing things in small chunks of work. Instead of releasing, maybe once a quarter, once a month, it's releasing every day, every hour, or much more often to get fast feedback on whether the things being built are the right things. There is a ton of overlap here with Agile and Lean principles. If you're interested in the things we'll be talking about today, you should check out that book, the DevOps Handbook. It goes into a lot more detail. And the first few chapters are actually pretty agnostic to an area of work. They're very applicable to actuarial work as well as software development. For today, we're going to skip a lot of parts of DevOps, like infrastructure as code and continuous deployment. And we're really just going to focus on continuous integration, or CI. So what continuous integration is all about, the basic idea here is really, it's a lot easier to fix an error when you make that error, right? Have you ever had the experience of starting a big project, and in the first week or so, you make a mistake, but you don't actually catch that mistake till months later. It's so much easier to find that at the very beginning when you make the error, right? And fix it then. And it's even easier to do that if your changes are small. That's the basic idea. What that then leads you to is you should be releasing your changes early and very often instead of only doing it at the end of your project, and very infrequently. How you achieve that outcome though of like finding those errors quickly is that every push of your code, every time you're taking that code and putting it up into the cloud, that triggers a set of steps called a pipeline that ensure quality. It's going to run your tests like Anton talked about with PyTest. It's going to do things like look at your code and make sure it meets standards. And we'll look at an example of that in a second. But just to make it really concrete, we want to give an example of how this is used today. So we have a pre-model process. When I say pre-model, that's taking data from source systems, reshaping it for the modeling system we're using. It will apply some assumptions, do some things like a premium roll forward, and then create those files that are then ready to be run through the model. That's under continuous integration. So every single change that gets made to that code is automatically ran through our pipeline. And it's making sure that quality is intact. It's making sure it's meeting our standards. It's also making sure that the results of that aren't changing. So if I'm making a change that is not supposed to have an impact, it's just maybe cleaning up some code, adding some comments, things like that, it ensures that that actually happens and it runs the entire process from end to end. If you're having a change that is supposed to make an impact to results, like maybe the premium is supposed to be higher, you can ensure that as well. Super valuable because, again, you can immediately see that the change that you're making is having the expected impact. And you're not having to really do anything. This is all happening automatically for you. So the system we're going to look at today is in GitHub. So we will share this example repository with you all. But what it is in GitHub, it's called a GitHub Actions. Now, just so you know where the pipeline is actually stored, and there's this .github workflows folder. In there, there's a .yml, that's called YAML. It's just a simple kind of configuration language. This is the pipeline. This defines all the steps that'll happen on every push of our code. I'm not going to read through it here because, again, we're trying to keep it high level, but just know this is how you could change your pipeline. Now, the view we will look at is you go to Actions, and you can see all the different runs that have happened. These runs with a green check mark, they passed. These runs with a X, they failed. So we'll look at a passing one. And you can see the way we have it configured right now is it runs on 3 different versions of Python on every push, just to make sure we're still okay with backwards compatibility. I'll just pick one of these. It'll be very similar. The only difference is the version of Python they're using. So the very first thing it does is it installs dependencies. So if our project requires pandas, it installs pandas. I'll show you this view where it actually show you all the packages that got installed. So I think this one does have pandas. It's using version 2.2.3 when it's running all this stuff. This is just good for debugging. The first thing it does is it's using a tool called Pylint to make sure there's no errors. An error is just wrong code that will not run. When your program gets to it, it would explode and your computer would start smoking, right? Warnings are a little different. Warnings are things that are valid code, but they're things you shouldn't do. They're very dangerous. They're unreliable. So we're telling it our code cannot have any errors or any warnings, okay? So that's just checking here, and we pass. Good. The next thing we're going to do is we're going to look beyond just errors and warnings. What about things like conventions or other changes, documentation? So you can see down here, it's found some issues in my code. I'm not documenting this module, right? Or here, I'm not documenting this function. Here, I am not importing my code in the agreed upon manner. These things aren't going to break the code, but they can, over time, accumulate and make your code hard to maintain. Documentation especially is an important one. This is something I value a lot. And so whenever I see this in my pipelines, I immediately go fix that, and then my code's better documented. What it does is it assigns those all a score. So my code as a whole had a 7.2 score out of 10, and we told it had to be at least 7. This is configurable. You could make it 8, 9. You could even make it 10 if you want. We just kind of want to say, hey, your code can't be total garbage. It doesn't have to be perfect, but it can't be garbage, right? But we passed that step. We're good. Next, it's going to check and make sure there's no vulnerable packages. One of the things with open source tools is there's some packages that are vulnerable. Maybe it's a fake package and it's just designed to steal your data. maybe it's something that could be exploited. But what we're doing here is we're making sure we're not using any of those packages. In one of my prior runs, one of those failures, I actually was on a prior version of Python. One of the default files in it was vulnerable, and it told me that immediately. So super valuable. Next, it's going to run PyTest. Anton already talked a lot through this, so I'm not going to go through everything. The important thing is it's going to run all your tests every time, right? So it's going to make sure that whatever you've defined here as important in a test is that's going to pass. And if it doesn't pass, then your project fails. This is really the most important part in my mind, is it's making sure that your code is still working as expected. It's also going to look at coverage. What coverage is, it's saying what percent of your code are you testing. So you could see overall, we're testing this one 100%. This one, we're only testing about half of this file. So there could be some errors here because we don't have tests written around those files. I'm saying here a 70% coverage ratio is what we're enforcing. You could make 100% if you really want to, but we're just making, again, some minimum standard. Now, this is a very simple pipeline. You could do things a lot more complicated than this, like, hey, every time I'm pushing to main, right, or on a pull request, I've completed a release, then publish a new version of my Python package to PyPy or to an internal repository, whatever it might be. You could also say things like, every time I finish a pull request, I want to take my documentation and publish it out to a wiki or a website or whatever it might be. Again, there's a lot of options here, but what this does, it automates a lot of really tedious things that in the past used to be very manual. Now they just happen automatically as part of the pipeline. And you get to configure this, right? You can say exactly what you want each of these things to do. You can add custom steps, all very configurable for what makes sense for your project. I personally, as an actuary, have found this something that I really could not give up now that I've gotten used to it, because it can give me so much confidence that the work that I've done is having my intended impact.
We have discussed several tools, concepts, and best practices, but if we were to highlight a few takeaways, we would start by saying there is life beyond Excel. You can use Python, Git, and DevOps to maintain everything you are currently doing while improving the efficiency of your operations. Also, to tie back to some of the tech challenges we mentioned at the beginning of the presentation, we talked about performance. With Python, you can handle millions of rows without freezing your computer. Traceability. Changes in Excel are difficult to track. Who made that change? When? Why? Now, by integrating Python and Git, you can gain full source control. Testing. By integrating Python, PyTest, and DevOps principles, you can create a culture of continuous improvement, allowing you to innovate without hesitation. Of course, this is not done overnight, but there are good news. You can start small, for example, by getting a free Python and VS Code installation, and then from there, incrementally, gradually grow with Git and DevOps principles. In conclusion, actuaries face many challenges in their day-to-day, and we believe some of these challenges can be solved by investing in your tech stack, leading to faster, more efficient, and more reliable processes. Thank you all for your time today. We hope you found this session informative, maybe even inspiring. And with that, we'll transition to the final round of live Q&A. Thank you.